Hello. I'll walk you through how we can turn a simple rectangle into a polar ribbon chart. So I've already drawn a rectangle to the screen. We've selected a root element, and that's going to be the container where we're rendering to. We've given it an X, Y, width, and height values, and a fill color, so we can change the color of this. The first thing we're going to do is make a bar chart, and we'll first create a stack of rectangles, one for every lake. So I'm going to do that by first adding this stack X operator and then a for operator, closing those parentheses. And now I just have to get rid of the X and Y values because the stack is placing the rectangles. And now we have an array of 6 rectangles. The next thing I'm going to do is set the heights of these rectangles to some data-driven values. So I'll replace the 300 with a sum over the count of every species in the lake. And then to make this a data-driven value instead of an absolute pixel value, I'll wrap it in the v function. And then finally, I need to add this shared scale to the stack X to tell GoFish that all of these rectangles are using the same Y scale. So now that the data is scaled, I can change the height of the chart itself and the bars will update. Great, so now that we have a basic bar chart, we can start adding axes to it. So the first thing I'm going to do is write axes true, and that's going to give us a y-axis because of this v function here. Now to add the x-axis, I'll need to add keys to tell GoFish which shapes or elements refer to what pieces of discrete data. So now that I've added the key field, I get these labels showing up for the rectangles. All right, now let's turn this bar chart into a stacked bar chart. We're going to add a stack Y and a for loop after this stack X and for loops. And we're also moving the key field up from the rectangle to the stack. And then I'll close off those parentheses. And finally, I need to change the height encoding to d.count. Great, so now we'll replace this absolute fill encoding with a data-driven fill encoding based on the species. And notice that we have a legend automatically generated from this fill encoding. We'll replace this lake here, and now within each stacked bar, we've ordered the species by their count. At this point, we can also play around with the specification a little bit more. Maybe we change everything to stack Y, see what that looks like. What if this is stack X? Ooh, now we get a grouped bar chart. The next thing we'll do is we'll use the connect X operator to turn this into a ribbon chart. So first, we'll wrap our specification in a frame. Next, we'll name the rectangle. And then we'll add our connect X operators, one for every species. And now we have a ribbon chart. It doesn't look like a normal ribbon chart, but we can change that easily by just changing the spacing on stack X and then changing the width of the rectangles. Now this is a really fun chart to play around with. If we change the width of the rectangle to 0, for example, we get these nice overlapping intervals. And if we change the opacity to 1, then we get these nice, more solid shapes. Finally, to make our polar ribbon, we'll add a polar coordinate transform to the frame. And now we have to change the parameters so that they work in polar space. So first we'll change stack X. Then we'll change the rectangle's size. And then we'll add some translation to keep the chart in bounds. And finally, we'll reverse the ordering on the stack Y, which is just another small bug. And voila, now we have this polar ribbon chart. And so we can start messing around with some of the parameters to stack X and see how that changes things. So what if I change this Y offset to 0? Okay, what if I change this rotation? I can make the spacing much smaller and get this sort of fan-like shape. And maybe I can change the rectangle size to be 0 like in the other one. And now we have this lovely continuous ribbon shape. You can even change the opacity here to 1 to again get these nice overlapping colors.